Today I have prepared for you a very essential area, and the area I want us to discuss today is all about probability. Specifically, I want to show you how to come up with the MGF of gamma distribution. That is it. Now you are provided with the PDF of gamma distribution as the one shown there, and from it we shall now come up with the MGF. And therefore, let us begin by now writing the MGF. Remember, MGF is being framed as the MT. So that is MT is the same as MGF. Now, how can I get MT? MT is just the same as the summation of exponential of Tx. That is it. After knowing that it is the summation of exponential of Tx, you need now to come here and say, how can I get summation? Summation, remember, this one is a continuous random variable, and therefore getting the summation requires you to use integration. And therefore I'll come here now and say that it is therefore equals to the integral of the limits. Remember, my limit here was from 0 to infinity. So that's what I write. So you'll come here and write 0 up to infinity. Then you now come and say that it is exponential of Tx. Just write exponential of Tx here times is the probability that x turns to x. And what is that probability? It is from the provided PDF. So the probability is this one here. Just take this function the way it is and write it here. So I'll come here now and say that it is x alpha minus 1 that is over gamma of alpha beta alpha exponential of negative x, that is over beta. Then you just write in a bracket. Then remember, I'm integrating with respect to x. So you come here and finalize by writing dx there. Now after that, you are now supposed to come here and now see a way in which you can simplify this. Remember, at the denominator here is all about a constant. Just bring these constants before the integration sign. And therefore, I'll come up here and say that it is 1 over gamma of alpha beta alpha is when now I write the integration sign. It is from infinity, that is a 0 there. Then I write the remainder excluding gamma of alpha beta alpha. That is it. So I'll come and say that it is an exponential of Tx. Remember, by the time I'm writing the remainder, it is better to consider that exponential and exponential, they are having the same base, and therefore just bring them together as you collect the like terms. So it is an exponential raised to this one, that is a negative x over beta. Then I write x alpha minus 1. So that is x alpha minus 1. After that, you come up and write dx, because I want to integrate with respect to x. Now, having done so, exponential, they are the same base, and therefore, the law of unity states that just take one base, and since the sign separating them is a multiplication, we shall just add the powers, and we shall have just done that. Therefore, I'll come up here and say that it is 1 over gamma of alpha beta alpha, and then integral infinity 0, that is exponential. When I come here, I need to come up with one exponential, and therefore x and x, they are the same power. Therefore I can write the result in a manner that I use 1x outside the bracket, in that I have t minus 1 over beta, then I have x outside here. This does the same thing. After that, I write x alpha minus 1 dx, and I shall have just done with that concept. So that is x alpha minus 1 dx. Now friends, after reaching here, you are now supposed now to write this value in a manner that let me just write it here so that you can see it. when I have t minus 1 over beta in bracket x, I can get the LCM of t minus 1 over beta. And the LCM here is all about, that is a beta. Then I ask myself that if it is t, meaning it is over 1. So 1 goes into t, into beta times. Beta times t is t beta. So I'll come up with t beta there, minus beta goes into beta 1 times, and 1 by 1 is probably 1. So I'll come up with 1. So this is the function I'll be writing there. Instead of me writing the whole of this bracket here, I'll come up and write this. And therefore, I'll come to the next step by saying 1 over gamma of alpha, beta alpha, the integral infinity 0, then exponential now. Now, with x here, there's a way I can write this x, in that I introduce a negative here that will probably affect everything that I've done here. And therefore, when I write x before here, it will be that it is a negative x. Remember, I've said that I want to introduce that is a negative on x, so that it affects the bracket here. Remember, the bracket I'm talking about, it is this one here, after getting the LCM and solving it. So when I introduce a negative here, probably the sign here will change, the sign here will change. When I say that is a negative x into now, a negative by a positive is probably a negative. I'll come up with a negative TB, then that is T beta. This negative will affect the negative here, and the negative by negative probably is a positive. So that one will be positive 1 there. Then probably it is over beta. This is what I'm talking about. And so far, negative and positive, according to BODMAS, positive come first is when a negative follows. And therefore I'll write 1 minus T beta over beta. That is it. So that's what I'll write here. So it is now negative x into 1 minus T beta over beta. Then remember, that is this content here. Then I write that is x alpha minus 1, that is the x. Now friends, after reaching here, I was integrating, and therefore when you flash back, by the time you are under integral calculus, remember you come up with several ways of which you can integrate, and one of the way is through substitution. And therefore, as I can see here, it is better that I use substitution method to integrate my problem here. And therefore, I'll just say that let this function here, excluding a negative, be another letter. Let me use y. So let x with the content inside the bracket be y. So let x into 1 minus t beta over beta be y. Now after letting x to be y, so far I can get my dy dx probably, and therefore I'll come and say, therefore my dy shall be, I just differentiate the function of y, and it is, when I differentiate x into 1 minus t beta over beta, I'll end up by having 1 minus t beta over beta. So that is 1 minus t beta over, that is beta. Then, because I was differentiating with respect to x, you just add dx there. Now after this, because I'm using substitution method, it is better to make both x and dx the subject of the formula. And therefore, first of all, I want to make x the subject of the formula. How can I do such? By so coming up here and now saying that, remember, x over 1 minus t beta over beta being equals to y, and therefore from here I can let x the subject by coming here and say by multiplying both sides by the reciprocal of the coefficients of x. So I'll come here and say reciprocal is beta over 1 minus t beta. So that beta over 1 minus t beta both sides. So beta over 1 minus d beta, whereby this one goes and remain with x being equals to that. So that is beta y over 1 minus d beta. After that, you are required now to make dx the subject again. Remember, I said that my dy was equals to 1 minus, that is d beta over beta dx. And therefore, I need just to make my dx the subject. And therefore, I'll come here and multiply here by the reciprocal. Remember, the reciprocal here is b beta over 1 minus t beta. So that is beta over 1 minus t beta. The same thing here. That is times beta over 1 minus t beta. After writing that, you cancel because these ones cancel and remain with the dx there. So you will end up by having dx being equals to beta by dy is the same as beta dy over 1 minus t beta. So 1 minus t beta. Now after making both x and dx the subject of the formula, now we can come here to our function here and begin now integrating. The constants remain the same, and therefore I'll now come and write the same constants the way they want. Now when I write that, it is now being equals to, that is 1 over gamma of alpha beta alpha, then integral of infinity to 0, then exponential. Now remember, we say that let y be x with the content inside the bracket, and therefore I can come to the content and substitute it with y. Therefore I'll end up by having an exponential raised to negative y, and therefore that's what I write here. So I'll come in up here and write negative y there. After doing that, remember I have x raised to alpha minus 1, and therefore what is x? Already I've said that x is beta y over 1 minus t beta. When I substitute it here, it will be beta over 1 minus t beta with the content. Remember, this is x, but x was raised to alpha minus 1. Now after that, remember I'm having here dx. And what is my dx? Dx is the same as beta over 1 minus t beta dy. So this is what I write here instead of dx. So I'll come here and write now that it is beta over 1 minus t beta, that is probably dy. Now after writing that, you now come now and simplify this bracket, because you can simplify this bracket. Remember, when you simplify this bracket, you will end up by having beta raised to alpha minus 1. So let me write what I'm saying. That is 1 over gamma of alpha beta alpha, the integral infinity 0, that is exponential of negative y. When I come here, this is what my major area of concern. So beta will be affected by the power. So beta will be raised to alpha minus 1. So that is beta alpha minus 1 over 1 minus t beta will also be affected by the same power. So it will be 1 minus t beta raised to, that is alpha minus 1. Now after that, you just write the remainder, because I was just concerned on solving that bracket. So the remainder is just beta over, that is 1 minus t beta, then dy there. Now after reaching there, you are now supposed to use the law of indices here to solve the contents that I'm having here. Just use the law of indices to solve that. I'll show you. Therefore I'll come here now and say that it is 1 over, that is gamma of alpha beta alpha integral, that is 0 to infinity exponential of negative y Now let us solve this using indices. The law states that when I am having no power on beta, I assume the power is 1. So I'll use the law of indices that states that when the bases are the same, the sign separating the bases of multiplication, what I do, I just take one base, as I'm going to do so. So I just take one base the way I've done so, that is beta. Then I add the power. Remember, I'm having power 1 here. So when I take 1, I add it here, it will be negative 1 plus 1, which is a 0, and 0, alpha plus a 0 is just alpha. You will end up by having alpha there. You do the same at the denominator here. Remember, the bases 1 minus d beta is the same as 1 minus d beta. This one here is raised to 1 because it has no power there. So I'll just take one base, 1 minus d beta, 1 minus d beta. Then I'll now add the powers. Remember, power here is 1. So when I take alpha minus 1 plus 1 is the same as negative 1 plus 1, which is a 0. So you will end up by having alpha there, and that is what I write there. Then it is dy, and you should write dy. Now after that, remember you are integrating. You can't integrate the constant, and therefore just take your constants and bring it to where the first constants were. Then remain with the values of the y's, because we were integrating with respect to y. So I'll come up here and say that it is now beta alpha. Beta raised to alpha is the same. When I multiply by 1, it's just beta raised to alpha. So that is beta raised to alpha. Then I divide by, when I take gamma of alpha, beta alpha, when I multiply by this one here, it will be gamma of alpha, beta alpha. Then I write this one because I'm multiplying. So that is 1 minus t beta, then raised to, that is alpha. Now remember, I need now to come and write the remainder. I need to come and write the remainder. Now, by the time you are writing the remainder, come up here to where I wrote that is beta, that is 1 minus t beta. Remember, this one, the whole of this was x. And what was my x? My x was by over 1 minus t beta. And therefore, I need to come here and write y. Remember, y is remaining here. This y here, it is remaining. So please substitute it here, so that the same y will be affected by the power as we've done here. So I'll do the same. Y raised to alpha minus 1. So y raised to alpha minus 1 that way. Then, since y raised to alpha minus 1 is here, it will also appear here. So instead of me having that is my dy there, let me have that is y raised to that is alpha minus 1. So alpha minus 1 is when I have my dy. Yes, so y was remaining, and that's why I have corrected it there. Please note where I've done the change. Now, having done that, so you are now supposed now to come here and write the remainder. Remember, the whole of these contents I've brought it here. Therefore, when I write the remainder, it shall be that is an integral of infinity to 0, that exponential of negative y, that is y alpha minus 1 dy. And remember, back to the function of gamma of alpha, you say that gamma of alpha is the same as this function here. And therefore, when I substitute this function here with gamma of alpha, I just mean the same thing, because that is what that function means. So I'll come up here and say that it is beta alpha over gamma of alpha, beta alpha in bracket 1 minus t beta alpha. Then I've said that the whole of this function is the same as gamma of alpha. You just come and write gamma of alpha there. Now, as you can see there, that there are some of the events or some of the terms that can cancel each other, like beta alpha can cancel beta alpha as well. Gamma of alpha can cancel gamma of alpha. Then you write the remainder. Remember, when I write the remainder, it shall be 1 over 1 minus t beta, then I raise it to alpha there. After that, you need to go further and write this function here in another way that is similar to it. In that instead of me having a fraction, I just have a 4. And therefore, I'll come up and write now the provided MGF, because that's what I've gotten. MGF now is the same as, for me to come up with the whole number here, I need to get the reciprocal of the whole of this content. Then I will get the power. So I'll come up and say that is 1 minus t beta. Then you just negate the power that is negative 1. And we shall have just come to the final answer of the getting the MGF. Otherwise, let me meet you in the next class. Bye.